Well, welcome all, and thank you for staying until the end of this presentation, or the end of this panel. And as Jimmy introduced me, I'm Karla Saldana. I'm an Ecuadorian architect and working with AI for the last 7 years. And today I'm going to talk about towards intelligent environments, expanding the space of possibilities. And before I move forward to some ideas and projects or research that I'm conducting, I want to first present my brain on how I think about developing these intelligent environments. And I think of them as this virtual representation of physical objects or systems that have this potential to revolutionize the way that we interact with the physical world. And they can help us be more efficient, cost efficient or cost effective, and build these sustainable environmental models to design, to construct, to simulate, and to do management of these physical assets. But I think in order to develop these intelligent environments, we have to have a cohesive pipeline or framework that builds theory, technical development, and physical applications. So I've tried to line up these 3 different lines of research. So I see, and I'm going to talk through them as I show you some of my ideas of how can we develop them. The first one is on the theoretical realm. So here we want to ask what makes this intelligent environment? And what is the difference between where we already have these ontological models or these reductive models like BIM or GIS to this intelligent environment, and what makes it intelligent, right? So if we look at the history of computation, we see that we've gone into this wild movement of decentralization from monofunctional machines to a world of application. So we've gone from one computer, many people in 1943 to one person, one computer in 1974. And today we have this one person, many devices. And all of them are collecting data, right? They are collecting data of our daily life, of our interactions with the web, and so on. The second movement, the one in 1970, changed our mechanical point of view from the previous one from the Industrial Revolution, which was more like an object, to a networked one. And this change of view allowed us to have practices that instead of having limited resources, now we can access a lot of information or big data to enrich our work. And thanks to this data, today, we have this also a lot of technology development that happened is that we created these AI algorithms that are based on machine learning processes, which are learning from the data that was created. The question that I have here, right, is what will our world look like? What's the next revolution that we're envisioning in 2050? And I want to make a guess, and I will invite all of you to also make the same, try to guess or try to answer this question. And I think I envision that we can perceive our world as an interconnected, intelligent environments at various scales that can help us explore possibilities, provide timely information for decision making, or contribute to solving some of the big environmental projects that we are faced in the physical environment, like weather-related hazards and different phenomena that we are experiencing. And I think in order to talk about these intelligent environments, we need to develop some technical implementations. And that's when it comes to the next branch of this holistic idea of intelligent environments. Creating intelligent environments means that we need to develop models, right? And here I always talk about playing models as a way that all the implementations that we have built throughout the years of practice and research, like for example, 3D environment creation, we have information models, we have data translators, we have AI models, all of them need to be all utilized in order to create these intelligent environments. And so for example, the 3D environments, they need to be enriched with information relevant at the scale that we're gonna be working on. So for example, we see that advanced computer graphics and modeling methods allowed us to create highly detailed 3D environments, and this is the case of BIM models. But other methods like encompasses this procedural modeling that you have some certain rules, and based on survey data, you can create an environment. Or we have the one that is also widely used based on images like photogrammetry, and I'm just giving you some softwares that I use to create these models. But right now, there has been a progress into using machine learning to create these environments, and that's this one over here. That's a model that a lot of you may have been used to create 3D models through images. And I want to emphasize on that one corner, because we know that the other models, right, we have the BEAM or the semantic modeling that takes a lot of time. We have the photogrammetric model that it has a lot of texture, highly texturized models, but they are not, it's really hard to combine the data that a BEAM model has or a GIS model has into this highly textured model, because they are a complete mesh. So what I'm saying, right now, we've created all of these data sets that are from different cities. And they're representing this physical environment. The question that I have is, how can we keep maintaining this big data set that if it took, for example, a year to recreate a city, how will you make decisions if a city evolves every second, every minute? So we need to be fast enough if we want to create this intelligent environment of cities, for example. What I'm proposing right now is that why don't we start creating a model that is as fast as the city that we are living in. And how to do that, and this is the work that I'm collaborating with colleagues at UF from computer graphics and also from planning, is to utilize these unique buildings to create a training data that will mimic what a drawn imagery looked like. So for example, here you're seeing the previous building, and we replicate the same camera angle, the same perspective and distances to the buildings from a drone to create a data set of thousands of buildings to train a new transformer to be able to generate 3D environments. The thing is that in the environment, you don't only have buildings, but you have vegetation, you have infrastructure. So imagine having at your disposal all of these different, very fast machine learning models to recreate physical environments. But why do we need them to be in that condition, right? It needs to be highly semantic, it needs to be a 3D semantic texturized model. Why do we need them? Because I think in order to create intelligent environments, they need to be intense, which is embedding and visualizing rich, multidimensional data sets. It needs to be immersive, which allows to enhance user experience and perception. It needs to be interactive, which is enabling dynamic user engagement and real-time systems feedback, and interconnected. And this is really important, and it's tied to the question that we just listened before, this bidirectional data connection. It needs to establish this two-way link between the physical and the digital in order to affect either of them. So we talk about 3D models, right? That's one of the models that we're playing with in order to create these intelligent environments. The next models are these, what I call informational models. And so we can have, I will present to you an example. I'm trying to create a digital twin of a city to help create climate resilient solutions. So here, in order to answer this question, I need to look at the different information models that a city contains. So for example, I need to look at the environmental information models, I need to look at the network information models, I need to look at the building information models, and I need to look at the citizen information models. The list that I have listed here, they are not holistic, not complete, but they are trying to grasp in one take what will be the need, what will be the information needed to enrich this intelligent environment. And not only that's important, but also be able to develop a aggregation technique that allows to, as you're shifting skills, the data is being aggregated meaningful, not only based on the features that you use from the information models, but on the geographic closeness that they have in the city. Because usually, when you think about digital twins, you want them to be used as I like what Jose, you said about technical objects. They need to be technical, but they also need to be something that we can work with. And in this case, at the scale of the city, you should use them to make planning, or make policies in a manner that represents the problem that you're trying to model, right? Information models. Next models. These are what I call model translators, and we've known that there are advancements in computer science that led to these physical simulators that can predict different phenomena and also predict or simulate different phenomena. But we also have right now something called surrogate models, which are also used to create the simulation faster. But the problem with those models that are simulating phenomena or physical phenomena is that usually their output cannot be directly interpretable into these intelligent environments. So when I talk about model translator, is how do we build protocols that we can take the output of these highly mathematical, complex physical models into platforms that allow to have a accurate representation of these very, in this case, flooding, environmental hazards, in order to help make decisions in the future. So build these models. Within these model translators, we also have, for example, I forgot to play the videos, but this is Jimmy's work, by the way. Thank you, Jimmy. So in this line of model translators, I think we have to talk also of the ways we interface with these environments, and of course also Jimmy's work, to think about platforms like XR to be able to be on site and then have ability to have to play with these information models that I just showed you before and experience different scenarios testing. And then how to do it in a closed room, but also creating platforms that are widely open and usable, so develop these web-based applications. So I talked about 3 models right now. I'm gonna move to the ones that I find it interesting to talk and maybe more developed. So we talked about 3D environments, information models, model translators, and now we're going to talk about AI models. And these AI models, we've witnessed throughout the last 2 years that before AI was understood as these highly data-dependent silos. So you have computer vision for images, you have natural language processing with text, you have robotics, hardware, software, and then you have, for example, expert systems, which were like these generative tools. But right now, we're witnessing these multimodal data fusion models, and we're seeing that machine learning has almost overtaken the new narrative of AI. So with that, maybe we can start thinking of what will be the interesting AI models that we can build into these intelligent environments. So I am going to show you some of the projects that I've worked on that I think could be an interesting way of navigating the space. So to create a multimodal fusion model to link images and text in order to find references of previous or historical events and curate your data set to work on the environment. This is also like a very almost not a these algorithms are already developed, which means that we don't necessarily have to develop them from scratch. So leveraging semantic segmentation models to be able to identify, in the case of flooding, what elements on the built environment will be at risk. And then, for example, another idea that I have is that we could develop pipelines to optimize resources. So in this case, we developed an algorithm to recognize and classify type of fruit trees for food security. So when a disaster happens, the first thing that you want to know is where your food is. And then if you're able to have very quick density map that is telling you where are the resources located, then we can develop these optimization models to either define paths to harvest them in the quickest, type of trees that you want to harvest, roads that you want to avoid, and in that way you can create a small simulation of events and then see what will be a course of action to take. So another, this is very explorative, so I believe you're gonna be dizzy. So generative algorithms, and I just want to kind of bring a theoretical framework, or at least what I'm currently thinking how to leverage them into these intelligent environments. So we know that these diffusion models, the diffusion happens after multiple steps, right? And these steps are they are, so if you slice this model, every single layer of the 1,000 layers that you have, it does contain an array that eventually becomes to the latent space, and then it is generated to the final output. For me, what is interesting to think is that the diffusion models right now are something I call human aligned, which means that they are always trying to generate what we think we want. So if we say we want a house, we have an idea of a house, and then the generative model generates the house. But if you think that if these models are human aligned, they may be constrained to only show us the things that we want to see, and we're not leveraging all its power, or not power, but all its intelligence, because there may be ways of in-between concepts that could arise by words that we may not know yet. So I think for me, what is interesting is not the final outcome, but is the in-between possibility space that I call. So I tried this quick exercise. So what you're seeing at the center of at the center of the grid, that's the image, that is the final output of a diffusion model. And I sliced the layers up to, let's say I used a prompt with 4 words. And then I wanted to see how these 4 words converge into the final image. And for me, it wasn't really important to see the final result, but it was actually to see what was around the final result, so I can find this in-between space and really leverage what I think this could be used for. So in another example, other 4 words, and then also try to see what is going on here. Right, with these, you can start really playing with other ways to interpret what you try to say and think, and then use this as a narrative to explain a project. So these images can then be curated into a narrative process that help you define what could experience of a site be if you're not constrained to the final, very beautiful image that you have through these diffusion model algorithms. So I said that for creating intelligent environments, there must be this technical development. So I just quickly show you 4 of the different models that we have to play with in order to create this intelligent environment. The other thing that I want to talk about is that intelligent environment for me is almost the end step of a continuum that I see of environments. So I think we've seen really good applications of environments that are representing existent content. So this is about creating geometrical or highly representative of phenomena or physical infrastructure. So that I could call a existent environment or a descriptive virtual environment. Then you have another one that I call the status or the informative environment, which is another layer of complexity from having this representative 3D environment plus this data layer where the information models come in. The next one, I call it a predictive environment, which allows you to have these AI simulations of physical environments embed. And then the next one, I call it this intelligent or comprehensive environment, which is leveling or leveraging every single implementation of the different continuums of these virtual replicas. So to move on, I have compiled 3 videos about different applications at different scales where I tried to develop these intelligent environments for tasks that are not designed, but are really into, for example, at the scale of the city, climate adaptation. At the scale of the building, is facility management, and at the scale of the landscape is exploration of the environment. So, just to tell you a little bit, University of Florida has invested several resources into developing AI curricula, not only in teaching but also in research, and there is investment as well into these projects like digital twin development, or what I call intelligent environments. Right now, these are the projects that I'm working on, but I'm going to show you only 3 of them, and they span on these different scales. So we have scale of the city, like the intelligent hospital. How can we recreate the environment for patients to come before they patients to experience the site before they are actually there? Can we keep track of the medicine in the pharmacy, can we keep track when do we have to refill specific medicine based on the data that you have in the model? Or how can you work with facility managers to help them not go, to go only to events that are worth going to check the building for? At the scale of the neighborhood, we're building all, most of the work that I show you with the 3D environment creation is invested into that scale, because we want to be able to control first this technological development and then apply it into a particular project. And then the JAX Twin, which is a very ambitious project that is trying to create the digital twin of Jacksonville in Florida. At the scale of the landscape, I think one of the constraints that we find is that landscape has the representation is really hard to digitally capture, because the buildings are geometrically sorry, this is like in automatic, geometrically straight, let's say, but the trees are not. So the way that we're thinking of a landscape is to be able to use other techniques. That right now we are we're pausing this project to give space for the buildings, but in landscape we want to develop that. And then some of these are explorations that we've done through these space of possibilities that I show you with the diffusion models, because I think landscape allows this freedom of experience and more than having concrete elements, which later we'll do, is to, for example, here was to imagine how would you feel. You will prompt the algorithm, it will give you these images, you will create your atmospheric feeling, and then you will go and design these on. And we use, of course, I was just talking to Hadin that most of the projects that I do, I use game engines, but it's more like for a visualization and exploration mode rather than as a tool for design. And I really want to build that in the future exploration that I have. So to go into like a much more applied project, so this is the JAX Twin. And the JAX Twin is a collaborative effort between the College of Medicine, the College of Engineering, the College of Design, Construction, and Planning, and is to model a city. And so what you're seeing here is about 32,000 buildings across Jacksonville, and we utilize this point cloud model and the 3D environment semantic modeling generation. But what it offers is that you can correlate different or several systems, including flood visualization and the interaction with the built environment. So here, for example, what we're doing is this building reacts to whether it's going to be flooded or not. And so you can really have this dynamic user feedback of when you're interacting with the model. We can also integrate additional data like transportation data, which could also be part of these information models depending on the question that you have. The third project, this is less fun, but I think it's getting to a point where we can find a direct use to these intelligent environments, and this is for facility managers. So we had a grant from the Office of Research, because the university campus has about 2,000 buildings. It's like a small city, and they want to be able to know when do they have to go and optimize resources. So we pitched the idea that we want to leverage Omniverse, which is a new NVIDIA platform for this 3D exploration, and bring a connection with the supercomputer that they have, so we can house the sensor data coming from the buildings on the supercomputer and directly apply those into Omniverse. And we did some use cases. So the first thing that we did is, how do you read this data and visualize it in a way that is not just a table or a pie chart? And so we are reading now temperature data from a room, and then the way that is being visualizing the environment is by changing the color depending on the reading that you have real time. Of course, this may be it's not as exciting, but I think it has future into how do you use these sensors or these IoT networks and visualize the data in meaningful ways. We also are running simulators, like for example, Energy Plus, that helps us understand the energy consumption of the building, and it provides a report that we can, anytime that we have a new input from the sensors data, we run the report, and then we know or catch the anomalies in the system, so we can recommend the facility managers to go and check. And then another case study is the construction monitoring phase. So we have low-tech hardware to monitor a site, and then we bring this hardware into Omniverse, and we check it with the BIM model that we have already from the building. And this is building a historical layer of different progress in the construction, so you can check, for example, change in volumes of construction or change in decisions as you go. And so all of these, it's embedded into these data set that we're building on our in the supercomputer. The third scenario, this was also like a quick exercise, is to like run some stressors on the building, like fire, and then have students try to decide how to navigate the building, and then define whether there were guides or if you could exit the building on time. So this was some, let's say, playful ways of finding case studies so we can pitch this idea, so to do this for every single building in our campus. So we've published some articles about intelligent environments, digital twins, machine learning models, and I just want to acknowledge some of the collaborators and the support that we get. So I work closely with industry partners, with NVIDIA, Siemens Autodesk, Immerse, and Mark III, institutions at the different colleges around the University of Florida, and then also I do have projects that are being worked in parallel at TU Munich and University of Hong Kong. So I am the director of the Share Lab. A lot of the work that I show you is in collaboration with everyone that is in our group. So the Share Lab is a spatial human-centered artificial intelligence research and experimentation. Very long title for just saying we work with AI. And the way that we work with AI is we see it as a two-sided. I think AI, when it's used as an instrument, can help empower creativity, and AI, when it's used as a tool, is good for social good. So I find these two differentiations, like the difference between tools and instruments, to be very relevant in the way that we work with artificial intelligence, because instruments like a violin, a pen, or a piece of paper really output something masterful if the one playing is as masterful as the instrument. But tools like a hammer or a motor really does not require that level of sophistication to produce a reliable result. So when you have problems with the social good, you need a tool that is precise and try to be optimal. And when you are trying to do creative work, you may want to have an instrument that is more like a collaboration to create. So right now, I'm about to finish. This is my last slide. Just want to give you a little bit of like what's going on in my life. I've been a professor since 2021, and there are several projects, but they have been kind of merged into 4 main projects that I'm working on. The first one is, how do we do this big data analysis for designers? How do we teach this in a design school? And how can we use AI to augment creativity? That's one of the things that I'm doing in my design studio. So I'm working as well with generative artificial intelligence for developing structurally informed 3D models. Right now we can generate 3D models, but what will be helpful is that we can know that they are structurally stable or structurally sound. How can we build that generative tool? And then I show you today the work that we're doing with digital twins, or these intelligent environment applications. And then the other thing that I'm really also torn to, just because of my PhD, is this idea of joining spatial features in the case of medical health or disaster response, to aid in public health responses. So I thank you.
Thank you, Karla, for sharing your research and teaching in experimenting how do we design this protocol for the intelligence environment. So now we are
your work last night, and I see you're also wearing your meta glasses, which will fold into this comment/question. And I was really interested in your Omniverse project and that kind of the potential for the smart building. And I come at that in a way, my husband's obsession for building our house as a smart home, which in my view has been stupid all the time. He removed all the light switches, he removed any kind of on-off facility for most things that would, you would normally anticipate that. So unless you have your phone, you're really powerless, literally. I mean, I remember standing once like, I've lost all the power in my house because I couldn't find my phone. And so there's the kind of, I guess, relationship between the technology and the usability. And I think the kind of Omniverse project has just such incredible potential. And I was just looking at the date of Wired magazine wrote an article in 2019, or it was a cover, which is like AR is sparking a kind of global mirror world, and the issue was called Mirror World. And we were talking last night about the previous iterations of these kind of smart glasses, and all of these fears going around 5 years ago, 3 years ago, whenever the next kind of iterative of these lenses comes out, and everyone's freaking out about being in a bar with someone who's recording, which you also did last night. And I remember when we were building the State Library, talking to the contractors, like, yeah, we're going to use these VR lenses and AR kind of tools to locate all of the structural systems three-dimensionally, and then they just had guys on ropes, pinning the stuff down manually. And so there's that relationship between this sort of like really incredible ambitions and visions with the technology, and then the reality that it sometimes or often becomes too complex to apply. And so I'm just wondering, because I think the project is genius, in part because Karla and I were like freezing 2 hours ago, and if I had access to this like spatial model, I would have like pinged somebody in who had Omniverse access and be like, can you move the room's temperature up 2 degrees? What do you think is the sort of real timeline potentially for a kind of smart system like this that would have overview of a building or a campus? I come at it from UCLA as well, where if we want to do any kind of maintenance or building, it's probably going to take 6 months just to get any kind of approval. So it seems to have an enormous amount of kind of organizational, bureaucratic, sort of holistic campus possibility. But like, where's the threshold between like just the things we're used to doing and kind of taking on board these tools in a fundamentally meaningful and productive way? What is that? What is that kind of, what do you think a real timeline potentially could be for this?
I will repeat the question. So based on what I presented, which is this envisioning smart buildings, or this idea of, or like smart buildings, what's the timeline of these being implemented in our daily life? So I think that we are already there. What we don't have yet is the ability to customize per user or per stakeholder request. So you're saying, in the case of I'm freezing, I'm sitting in this room, I would like this to be, temperature up. But then the facility, the university president wants to reduce expenses, and he will not like to change because changing temperature every hour will increase this much, an electricity bill thing. So I think we have the technology to get to that level. I think we have to develop the specific user interfaces to react to the environment in a cohesive and as well meaningful way. So if you're a user, there should be a way that you can access to the model and also be able to change. And then this model doesn't need to be approved by the president, but kind of has already inbuilt rules about how much degree of freedom you have to make decisions of a room. Because imagine you say, I'm cold, I'm hot, I'm cold, I'm hot. So the whole thing is just never, it's a DC and doesn't know what to do. I put this timeline of 2050 just because I see, and I want to see what's the next 20 years. I want to think about the next 20 years. And I don't know if we will have these platforms developed by 2050, but I think we will know how these platforms look by then. Maybe that's an answer. I don't know if could count as an answer, but I will stop there.
Yes, another.
Hello, can you hear me? Okay. I really liked your presentation, of course. I really enjoyed to see the ways in which AI models have been used to map out buildings in depth, and particularly speaking on the same concept of being able to interact with the environment. I really like the idea of creating a tool that sort of merges that aspect of having a full concept of the building as well as being able to interact with your surroundings. So I guess my question is for this specific tool, I know that, for example, the architecture building at UF, it can be very confusing for many students. So I think that it would be interesting to integrate a sort of almost like orientation style agent that facilitates a walkthrough of the environment, as since there is a clear mapping of each individual building and there would be sensors within each room to create an almost like interactive way through XR methods to allow the user to step through each building and maybe be followed by some AI virtual agent that facilitates the exploration. So this would also remove the middleman in many scenarios, which is having to hire someone to guide an orientation through a building, but instead having an encompassing environment led by an agent through some kind of XR environment that can dictate and explain everything in the surroundings, because even though it is clear that you can walk around and you can see the different rooms, I think it would facilitate to have some kind of guidance as to what each room details and what the purpose is. I guess, in short, I'm trying to see if there's any room for some kind of virtual agent implementation for these models, building models, to sort of facilitate the explorative nature of the tool.
And thank you for the question, Reggie. He works also with me. We work together, let's say. I think there is already these agent-like characters, and I'm just playing this intelligent environment because the whole hardship, like the whole, why did the hospital was modeled up to the detail of the handrail on the door, was to be able to have this like experience before you go to the doctor. And then you will have a nurse that will explain you the procedure while you are in this virtual environment, and will tell you, like you will have a GPT embedded into the nurse, so you can ask follow-up questions on your procedure. So you can talk like the whole night before, the whole day after. Like you can have these as your pocket doctor, like for just to ease your way to your appointment. I think I see the difference between the way that the intelligent hospital was conceived as these like more user-based, like we're going to replicate, we're going to model the environment. The environment has no data, so we don't know the brand of, like the brand of the chair, or we don't know how many tables we have. We're not caring about that, but we're caring about building these agents, these intelligent agents for interaction. But the difference between this project and this one of the building itself is that this building has it's highly information dense. So we have information about every element, and we get sensor data from the lights, from the AC system, from many other embed sensors in the building. So the question here, I mean, you can always turn say why don't have both. But right now we're looking at that, and in a follow-up project, we're thinking about bringing this AI agent for different questions, like students that are coming to class, they want to navigate their campus, how do they go this place, and like help them with their scheduling of rooms and things like that. So I think it is possible, it's just that it requires a lot of people, and we don't have this many people.
Thank you.
Yeah, thanks so much for the presentation. Maybe it's a two-parter question, I'm not entirely sure, but we'll see. So, I don't know if you're familiar with this short story by Luis Borges called On Exactitude in Science.
Yeah.
For those who don't know, it's the story of a map maker who continuously increases the resolution of the map that he's making. So eventually, the map that he produces is literally at the scale of the city. And I'm wondering, in your case, with this digital twinning, at what moment is the resolution enough? Or at what moment have you, is there a moment where, what is the, how much data wants to be integrated? But then there's a second part to the question. But if you want to answer that one.
Yeah, I can, because, so the idea of only having one map is something that I would like to avoid, right? I think we should have as many maps as data allow, and as many models as maps we have, right? More than maps. Like I have this, I'm fascinated about this question because my PhD is about map and models, and it quotes Borges. So, but to go back to when is enough, and I think one of the developments that we're doing with these information models that I presented here briefly is this idea of minimal units of data aggregation. And that defines the level of detail that a different scale should have. Like, for example, at the scale of the building, the detail depends on the question that you're trying to solve. Like, if it is about facility management, the level of detail should be the assets itself. You need to know where they are, and then they need to be connected to the physical environment. And that's the minimal unit of data aggregation are assets itself. If you go to the level of the city, you don't need to know how many lamps a building has, but you need to know that the building has a roof, how many doors and windows. For example, in Jack's Twin, or in a project that we're working with Campus Resiliency, we need to know the material of the walls and whether the building is elevated or not, and whether there is like the topographical ground and permeable and impermeable surfaces, because we're going to work with flooding. So I think there, for probably the minimal unit of data aggregation could be the building. So everything is going to be aggregated at that level. But then if you go to the city scale, probably the building is not meant for policy making, but then you need to define what's the unit of aggregation. Right now in policies, you use the zip code or the census tract units, but they are not representative of problems that the city has. So how do you define a relevant unit of data aggregation that is responding to the question? And here, for example, these maps here are just doing that. So when I'm saying like the different zoom levels, this is creating new units depending on how you're zooming in or zooming out of the city scale. And I have not answered the question there.
Yeah, no, that answered it perfectly. Thank you. And then the second part of the question was, so on the question of the flooding, it's obviously super important, like the impacts that would have in terms of life saving and so on. And I was a little bit curious about how far back down the chain of the prediction model you might be able to go, or in the 2050 vision might you want to go? So for example, the flood is the consequence of something that then is the consequence of something, right? So yeah, maybe that's the question there.
So because I'm not a modeler, I'm not an engineer, we rely on highly computational expensive models, like the one that you're seeing on the left. This is the output of a flooding model that is taking oceanographic data, environmental data, and existing sensors data on the shorelines. So it is a very complex and very detailed model that, though it predicts flooding outputs, still it requires a lot of computational power. Like the problem that we have, and then you'll see in this video, is that the output for that model to be able to compute in 15 days, it will only compute of the scale of 50 by 50 meters. So, 1 feet in a 50 by 50 meters makes no difference. So, what we're like, I think probably there is work with the surrogate models to expedite the simulation process that I see will be here almost. But I still believe that people don't pay attention to this translation moment, because we do have research on that end. Like engineers, like modelers in engineering know this very well. But the way that when you bring that into an environment, there is a very complex process that you need to figure it out in order to make it accessible, immersive to the environment. So I think we are already there, but this is the part that we don't know yet, or we are trying to get to.
And maybe just the last follow-up question on that one is, how important is the visual fidelity to maybe a more abstracted representation?
So I like switching slides, but this is the slide that for me it's kind of, I call it intelligent environment with 4 eyes. So I put here like this idea of immersion as being important when you're creating these intelligent environments for decision making. And I'm just making these narrow down for related to natural hazards, because it is not about designing a house in a beautiful field, like a beautiful mountain. This is designing a house for a specific hazard-related event. So I think immersion is relevant for that case study, because you always have this answer when there is someone that lost their house, is that I didn't expect this. Like that's the first answer. Like we never had been flooded, so therefore we didn't act. So I think for this case study, it really needs to be as close as possible to reality. But of course, for other case studies, I don't see the need to invest into that line. But I think for these, that's my answer.
Hey, Karla.
Hi.
I think that what's interesting, or what I'm thinking about, is that, and we've worked together on different things too, that like, it seems like there's a kind of human question behind this, all of this, right? Because you just said, a lot of this is to support decision making. I know the projects with Jeff and Fiber are about communicating, right, the sort of effects of flood, right? And many of us have been to airports, places where the restrooms have that like little LCD panel where you say how satisfied you are with your bathroom experience. I don't know how many of you actually touch that thing. Right? Or even the sort of discussion about the temperature in the room is ultimately comes down to like, what do we decide to do with the data and kind of communicate, right? Because behind all this, ultimately there's a sort of human decision that has to happen with it, right? And or eventually if we can codify it in a way that's, I don't know whether it's like actually about equitability, or because I know, like in my case, for example, me and my wife have drastically different temper ranges that we're comfortable with, right? And so sort of negotiating that in a way, and even to kind of the notion of how do we apply, sort of AI methods to design, is about the kind of decision-making process. And I think, the sort of broader question is actually where with all these tools and data, right, that let's say you have also kind of created, constructed, like I think then there's a sort of jump in the gap of basically connecting it back to the human or the decision maker or the designer or the person. I think, and I'm curious about what you think about that.
I think thank you for the question. The question is about how do you decide who makes the decision, right, using this technical object. I think what makes sense is to, even before start working on a project like this, have a clear understanding of the user and what you're trying to solve, at least like to constrain your information models. Because I don't think you can be complete. Like you cannot model a whole entire environment and try to ask any question. I think trying to be general from the very beginning, it doesn't take you anywhere. So for us, it depends on the scale and depends on what's the physics that we're modeling. Because I think in the intelligent environment, the idea of having data-intensive, 3D environment, immersive, then you have physical modeling, and then also this ability to bring these AI models based. So these really depends on who will make the decisions or who is going to be using this and what's the problem that you're having. So I don't, like for example, for the building, we already know that this is for facility managers. And we can leverage all the effort that we did on building the digital twin, but think of another user, like for example, students. So that should be a different set of data that you will see, they will see or they will interact with than facility managers. And then in the case of the JAX twin model, we always thought of as policy makers. So these are like the people who have power in making lives easier or harder, but sometimes they lack the ability to understand space. So sometimes the idea of consensus making, when you show them a map, someone is thinking of it in a way that is different than the other one, than the other, than the other one. In creating a tool that allows to have this consensus making, then probably they can make decisions in like understanding everybody's exactly.
Can I build up on that? I think that this is like a really fascinating conversation, which it's still the question. I still have the question of what about those kind of uncomfortable questions that the model might be able to answer, but might not want to answer. Like it kind of harkens back to the question that Dr. Peter had to, like how much does your building weigh, right? There might be that the model can tell us a few things, but maybe some users will be restricted to ask certain questions. I wonder, like from this perspective of the public access, right? Would you imagine a version where all questions could be asked to the model, or there's certain questions that are kind of assert a certain truth, right? A certain kind of fact making that kind of make it smart, and there may be some questions that would be, forbidden or kind of.
I think this goes back to this interface making, and I don't like. We have these conversations with the information team, like the IT department from our university. Is that we are very scared that this will leak information to people who would like to harm us. So we should restrain this to only these many, users. And then facility managers need to have a greater extent of available, like to see more things than students, but then faculty. So I think right now, it probably for these applications, modeling the stakeholder needs is one of the first goals, right? Because yes, sometimes you as a student want to know a bit more, but this depends on the privacy issues of the whole institution. So if you were, I don't know how to answer this other than to say, sadly, you cannot let the freedom on applications like this because of privacy issues. But if this was something that was more explorative, probably you would like to enhance this, break it, or use it in a different way than it was planned, just to see what's the limits of what you can do with this.
Thanks for the talk, Karla. As always, an insane amount of projects, it's just, it's always nice to see how these things are going about. I'm just thinking, and this came from recently looking at, the new GPT-5 and interviews with Sam Altman and this and that, and then somehow they're talking about, okay, now the internet will be accessed through these models, right? And then you just go through them, so they become a kind of middleman, and then there will be more middlemen, and so on and so forth. And the US is kind of like that, right? You have your insurance, and then you have a broker for your insurance, and this broker has a consultant, and this consultant has a secretary, and this and that. And it's a kind of massive, kind of weird, invented economy, right? It's cascaded economies where everybody seems to be making money somehow. And also related to this Borges story where the model, where the map, eventually it breaks down, and then people are living under the broken pieces of these models. So the premise of the foundation models was really that they would have the ability to actually consolidate models, right? That they could have a lot of these modalities, they could have any kind of media, and they would bring things together. But what seems to be happening is that there is becoming more and more and more models nested, cascaded, and so on and so forth. It has massive economic kind of consequences, and also complications. So it's not complex anymore, it's just pure complications, right? And there are very few protocols that can actually communicate in between models. So and this is a kind of sudden thought, I'm just wondering if this is really what's happening now. It's not about consolidation at all, it's about selling a new model every day, making money out of that without ever addressing the problem at hand somehow. How do you see that going about today? Like, how do you consolidate things? How do you bring them together, and so on? How do you end your outlook for the next 10 years or so?
I'll try to summarize your question. So we're seeing now that the development of AI models, rather than going towards this foundational, general application or general architecture, it's going into a nested, creating a pipeline of different AI models that can feed the next one and the next one and the next one. So I don't know if I'm wrong, but I'm going to tell you what was my first reaction to this. I do believe that we've created a foundational model when we thought about the neural network. And I think if in order to move forward with another foundational model, we need to move away from neural networks. And right now, every single model that we have is based on the architecture of a neural network, regardless of the learning process, right? So we have transformers, we have unsupervised learning, supervised learning, reinforcement learning, all of that, but they are all embedded into the abstraction of our neurological system. If you think about what's the future of AI, if not these nested AI models, one feeding the next and the next and the next, I think that's it. I think we need to move again away from this idea of neural networks, because they have already proved to be the foundational models. They have been used and are used in every single application of the most powerful GPT models, for example. I had this fascinating thought that the way that I see models to go against this neural network is to, right now, the models are as good as the data, right? If you have more data, then they converge faster, they learn more. But sometimes questions don't have that many data. I probably think that to move forward, to develop these new AI models is to be able to predict with few samples of data, similar to how we actually create the model of the world. So I think how we are able to exist is through making predictions every second of our life. And how we do that is because we have modeled our environment and we have already created a model of the world. So I think the next foundational model will be a model of the world, where you don't need to keep adding data, but it kind of understands the interconnected relations of things. Like, I know that if I touch this is hard. And if when I touch it's not hard, then it will recalibrate my idea, but it will never it will let it be. It wouldn't be like adding more information. So the idea of the middleman, I think a way to avoid it is, maybe this is to learn what AI really is. because I see a lot of the companies that have been creating using these GPTs are just doing that. They are not leveraging other applications, and I think like the traditional AI could even be better at solving some of the problems that we use in GPT to do it. But I don't know if that will happen. I don't know how to, like, I will maybe just collaborate more with these companies, train kids to understand how it is so you make an AI model, maybe. I
Thank
think.
you. Thank you, Karla, for doing this meaningful discussion. And then,
Thank
I'd
you.
like to